Oh, hi everyone. We are solving radical equations that have radicals in them. And really the big goal is to just kind of isolate the radical. I can do it on this one by adding x to both sides. And I get the square root of 2x plus 7 equals x plus 2. And then once you have the radical by itself, then you can undo a square root by squaring both sides. And so that's what I'll do here. I'll raise both sides to the second power, and then the square root and square are going to cancel out, and you have 2x plus 7. And then if you multiply this out, that's x squared plus 4x plus 4. And I'm going to subtract 2x and 7 from this side because we've got a quadratic now that we can solve. And that's 0 here. And x squared plus 2x minus 3 multiplies to negative 3, adds to 2. We can factor this. I got x plus 3 times x minus 1. You could use quadratic formula. You can complete the square. But factoring, if it works, it's maybe the easiest, especially. So x plus 3 equals 0, or x minus 1 equals 0. So I'm going to subtract 3 from both sides, and I've got x equals negative 3. I'm going to add 1 to both sides, and get x equals 1. Now, you've got to check for extraneous solutions. Okay, we are just solving within the set of real numbers. We're solving for all real numbers that would work, and negative 3 and 1. So I'm going to check negative 3. I'm going to take 2 times negative 3 plus 7, subtract 1, and see if that's going to equal 2. So this is the square root of 1. Negative 67 is 1. Minus 1, that's not going to equal 2. That's 0. Okay, so this one is extraneous. And checking x equals 1, I'll take 2 times 1 plus 7 minus 1. Okay, just occurred to me, I'm subtracting x, I'm not subtracting 1. So I'm going to put a 3 here. Okay, I still think it's a problem. 1 minus 3 is negative 2. And that's still not equal to 2, but make sure you check it correctly. So now the 1 goes here. Does that equal 2? This is 9. Square root of 9 minus 1 equals 2. 3 minus 1 does equal 2. So x equals 1 is the lone solution there. Alright, now this example, square root of 2x minus 5 minus the square root of x minus 3 equals 1. Now I could square both sides. I will tell you, you have to FOIL that out though. And that's probably not as easy as it might seem. So what I'm going to do, when I have two radicals, I want to get one on one side and one on the other. It's x minus 3 there. And what do we have when we do that? We've got the square root of 2x minus 5 equals 1 plus the square root of x minus 3. Now I'm going to square both sides. And the square and square root cancel out here. That's 2x minus 5. When I square this side, first plus 2 times the 1 times square root of x minus 3. When I square the square root of x minus 3, I get x minus 3. Alright, let me simplify a little bit. 2x minus 5 equals, let's see, I've got the x, I'll start with that. Negative 3 and 1, that's negative 2. And then plus 2 radical x minus 3. I'm going to subtract x from both sides. I'm also going to, I'm just trying to get this by itself. I'm going to add 2 to both sides. And 2x minus x is x. Negative 5 plus 2 is negative 3. And that's equal to 2 times the square root of x minus 3. Okay, two options here. I could divide by 2 on both sides. I think what I'll do is I'll just include that in the squaring here. And I'm going to square this. And I have x squared minus 6x plus 9 equals 4 times x minus 3. 2 squared is 4. Square root of x minus 3 squared is x minus 3. So what do we got? X squared minus 6x plus 9 equals 4x minus 12. I'm going to subtract 4x from both sides. I'm going to add 12 to both sides. Because when I have a quadratic, let's see, that's x squared minus 10x plus 21 equals 0. When I have a quadratic, I want to just solve completely through. This looks like it'll factor. Okay, and x minus 3 equals 0, or x minus 7 equals 0, and x equals 3, or x equals 7. I'm going to plug these in. Square root of 2 times 3 minus 5 minus the square root of 3 minus 3. Is that going to equal 1? This is 6 minus 5. So square root of 1 minus square root of 0. Yeah, that's going to equal 1. That's 1 minus 0. Okay, so 3's working. Let's see if 7 works. Square root of 2 times 7 minus 5 minus the square root of 7 minus 3. Is that going to equal 1? This is 14 minus 5. That's square root of 9 minus the square root of 4. Is that going to equal 1? This is 3 minus 2 equals 1. Yep, it's checking out. So this one has 2 solutions, whereas the first one had 1. All right, example 3 here. So here we have a cube root. That's the one that's different about this. I'm going to try to isolate it first, like we did before. Cube root of 6x minus 3 is equal to 4. Now this divides nicely. That the previous one, I decided not. Where was that? Right here. I decided not to divide both sides by 2 before squaring. I am going to divide by 2 here. Although I could leave it there as long as I remember to cube the 3 when it's that time. But what I'm saying cube here, because this is a cube root. To undo a cube root, you need to raise to the third power. Third power and 3. So we got 6x minus 3 is equal to 8. And I'm going to add 3 to both sides. I get 6x equals 11. And divide by 6. And x is 11/6. And it's not as bad as it looks. To check it, cube root of 6 times 11/6 minus 3. Now subtract 4 from that, well, we get 0. So that's 2 times the cube root of the 6's cancel. That's 11 minus 3 minus 4. Is that going to equal, question mark, if I can draw one, 0. 2 times the cube root of 8 minus 4 equals 0. Cube root of 8, 8's 2 to the third. Third power cube will cancel. That's 2 times 2 minus 4 does equal 0. So this is working out fine. All right, guys, take care.